Okay, in the name of God, we start our first session of our course. As you know, the title of your course is Advanced Algorithm. This course is the combination of machine learning algorithms and a little about the traditional method in the field of pattern recognition, and at the end of this course we will talk about the deep learning algorithm using Python a little. If I want to talk about the details, this first we will talk about the course introduction, references, and evaluation. And then also we will start the fundamental of machine learning. After that, about the in this session or other sessions, we will talk about computational methods for data analysis. For example, in this section, we will talk and we will learn about time frequency analysis. I'm sure you know about a Fourier transform, but we will see the details and example in this field. Beside the academic and theoretical lesson, we will see MATLAB code in this field, and we will run it, and you will see the result. And my purpose is you will familiar with MATLAB, and after you write the code, you change the parameter of MATLAB code and see the effect of different parameters in different fields. And don't worry about the MATLAB code. Our references themselves have this code. You only want to run it in MATLAB and see the result and change the parameter. Okay. After time frequency, we will see a little about image processing and analysis in MATLAB, like the previous subsection. In all the subsection, we have MATLAB code. Another thing is that linear algebra and singular value decomposition. As you know, in the field of pattern recognition and machine learning, one of the most important topic is feature reduction or dimensional reduction. We will familiar with this algorithm like SPD, PCA, and ICA, independent component analysis principle. Let me to run my pen. Principal, component analysis, independent component analysis, singular value decomposition, and the last one is dynamic mode decomposition. Dynamic mode decomposition is also the new algorithm in this field. Besides, we will also familiar with image recognition. As you see, it is singular value decomposition and linear discrimination analysis. For example, we will want to recognize dogs and cats. And as you see, we will down it with MATLAB. Okay. One of you asked about MATLAB or Python. At the first, in this subsection, I said we will run it with MATLAB, but at the end we will arrive it. At the end, we will run it in Python. We want to familiar with both of them, MATLAB and Python. The first algorithm with MATLAB and the last one with Python. I will say which of them with MATLAB, which of them with Python. And another major and essential in this field is clustering and classification. You know, in the machine learning, for example, after we have data, we have extract a feature. I will write it with my mouse. Then my writing is not so nice. Okay, we have feature extraction. After that, we have classification. Then we have many algorithms for feature extraction, and after that we have many algorithms for clustering and classification. Okay, like SVM support vector machine tree, classification trees, and random forest. And we will introduce top 10 algorithms in data mining. Okay, this is till this topic. After we finish this topic, we will start a new field, neural networks and deep learning. From here, they are in Python. After introduction about neural networks and deep learning, we will run it in Python. I will send this file in LMS, and then after that you can see the details of our content course, step by step. You yourself can see it. Okay, and if we have time, we can see and we will see applications of data analysis in this field. For example, music genre identification, oscillating mass and dimensionality reduction, image denoising through filtering and diffusion, analyzing music scores, and the Gabor transform. We will see the application using these algorithms. Okay, and another thing in this file, if you pay attention, I write in the parentheses, for example, A, C. Okay, A is the reference that I named it A. For example, here, this is your references. Reference A is about the machine learning. Reference B is about data-driven analysis. I will send them for you in LMS. Okay? Don't worry about it. I'm sorry. And another thing in parentheses is for myself. S1 is session 1, S2 is session 2, and maybe I erase it. This is for myself. Then when you want to study these subsections, for example, if you want to want to study time frequency analysis, you must refer to C. Reference C is here, and then in part C, part 3, 30. Okay, here you see time frequency analysis. Okay, besides the references, I also prepared PowerPoint. PowerPoint is here. Again, I must say that I will also the PowerPoint for you. PowerPoint is the abstract. For example, this is about computational methods for data analysis, and it is about the time frequency. This is the abstract of this chapter. It is a C reference. Then you have the reference, you have the PowerPoint, and beside all of them, you also can see again our online video in Adobe. And anyway, if you have any question, you must and you can ask me in Telegram in our online Adobe classes. Surely I will send them. One of your students said please send the PDF. I will send all of them for you. Don't worry about if you need it, because I want all of us have the same reference, have the same PDF. Then I will send them that we use these references. Okay. Another thing that I must say about the evaluation. About the evaluation, I must, in my Iranian classes, I don't say my evaluation in the first session. After, I don't know, 5-6 sessions, after I see your feedback, I know and I will familiar with you. After all of them, I decide how to evaluate you. No, my screen is shared. My screen is shared, but it is in Adobe. It is not our lesson. It is in Adobe. Okay. Then please let me wait to get your feedback about this lesson, about our relationship, and then I will say how I evaluate you in this course. Actually, I think about it. Maybe I introduce some projects for you, or maybe I ask some questions as a quiz in LMS. Like this, it is like this. It is not very difficult way, but the exact evaluation system is not very clear here. And at this time, I will say. Okay, if you have any question about the content, about the evaluation, about our class, please ask. Please ask me. If you want to know something about our course. Okay. If you don't have any question, we will start the course. As you see in the content, our first session is about the fundamental of machine learning. We want to see what is machine learning. I'm sure that you hear about machine learning. I'm sure. But we want to review it, and step by step we want to familiar with machine learning algorithms and topics in this field. The total goal of this course is that you will familiar with, for example, if you want to run a pattern recognition project, you must know what is, for example, feature extraction, what is classification, what is the method, like this. What is, for example, one of method for classification is deep learning. One method for feature extraction is neural network. The total goal is this. Okay. Now we want to know what is machine learning. As you know, when we want to analyze data, we have different methods. Okay, we have different methods for signal processing. We have different methods for image processing. We have different methods for data mining. Okay, machine learning is the science and art. Is the science of programming computers to learn from data. For example, if you have data like this, cross, triangular, squares, circle, we have all data is this. For example, we want to program computers, for example, to classify cross from triangle. How to write code to distinguish these objects. Okay, this is the science of machine learning. For example, they have many different definitions in this field. For example, one definition is machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. What is this? We will familiar with this definition in next slides. Okay. In traditional programming techniques, for example, if we want to diagnose or to recognize a spam email. Okay, we using traditional programming technique. At first, we must know what is the spam emails. What is the content of spam emails? What words we see in the spam emails? We definite these words. For example, we say if we see for you, if we see credit card, if we see free, if we see amazing, if we see these words, these phrases, then this email is spam. Okay, we know the problem. We know the problem. Our problem here is distinguishing these words in the emails. And then after that, we write rules. We write rules to distinguish these words. There are many rules. At this moment, we don't want to know what is the rules, but we know there are many different rules. Anyway, after we know the problems, we write rules to solve this problem. And then after that, we evaluate it. After evaluation, if we can recognize for you, I don't know, credit cards, free and amazing, if we can recognize these words, then we must be so happy. Okay? But if after our evaluation we don't be successful, we have some errors, then we must analyze the errors and also consider the problem. And then we, for example, update our rules. Okay? We ourselves must do it. We ourselves must study the problem again and analyze errors. Maybe they are automatic or semi-automatic, okay, or non-automatic. But anyway, we must supervising this progress. This is related. This progress, these steps is related to traditional programming techniques. Okay? And at this moment, we want to know if we use machine learning algorithm, what is the advantages with compared with traditional programming. In machine learning, we have data. Okay, we must have data because the definition of machine learning was programming computers to extract to learn from data. Okay, then we must have data. And we must study the problem. For example, again, if we again consider the spam filter, we have a spam filter and we know what our goals. Then we must train machine learning algorithms using our data and by considering the problem. Okay, and the machine learning algorithm train it and evaluate it. If it is okay, we will happy. If not, we will sad. But what is the differences between this diagram and the previous one? For example, for this problem, machine learning techniques automatically learn which words and phrases are good train and itself automatically learn about which words is related to spam emails. In these techniques, we don't exactly define, for example, for you credit card fee and like this is related to emails. They automatically learn, automatically extract these words. How? By using data with different algorithms. At this moment, we don't know the algorithm, but they have this facility. Machine learning algorithm have this facility to learn from the data what is the spam. As you see, it is so dependent to data. Okay? If you have any question, please ask. What is difficult? Miss Zahra, what is difficult? Step by step, we will be familiar with it. We will see different diagram. What is your question? I don't understand your here. Okay. One of my character is that I repeat again and again one thing. When I'm sure about you learn, I pass it. Okay, don't worry about it. Then another advantages of machine learning, if your data updated. For example, you have data, you have emails. For example, you have 100 emails. Okay? You have 100 emails. But after that, we have new emails. We have, for example, another 100 emails. In the traditional method, you again must see this first 100 emails, extract the words, and then write the code, evaluate it. Okay? In machine learning, but if you have new data, you add new data to the previous data, because the machine learning learn and train about the first 100 emails, then we are not worried about the new ones, because the machine learning algorithm learn and train with the first data. It is the advantages of this machine learning algorithm. Then our diagram again updated. If we have data, using the data, our machine learning algorithm train, and if we update the data, then we are not worried about it, because the machine learning algorithm can evaluate themselves, can update it themselves automatically. For example, if we have a neural network, deep neural network, we use one of our data for train, and the rest of data we can use them for test our algorithm. And this is the advantages of machine learning algorithms. Okay. if we summarize our machine learning, this is again about the advantages of machine learning. We are using the machine learning. We also can learn from it. For example, if the data are related to spam email, and the machine learning algorithm extract the spam emails, okay, we, after the evaluation, after extract these spam emails, we can see the result, and we learn about the result. Then the machine learning algorithm can help us to learn about the problem. Okay, anyway, this is the summarize. This slide is the summarize of our talking about machine learning. For example, problems for which existing solution require a lot of fine-tuning or long list of rules in the traditional. But one machine learning algorithm can often simplify code and perform better than the traditional algorithm. We describe it. We know complex problems for which using a traditional approach yields no good solution, because they are complex problems, and maybe traditional are not good for them. But the best machine learning techniques can perhaps find a solution, because in the machine learning algorithm, our algorithm automatically see the data. We feed data to machine learning. Then they themselves consider all the data without any error. We see the machine learning system can adopt the new data and getting insight about complex problem and large amount of data. If we have complex problem or large amount of data, the machine learning is the best candidate to analyze them, because they automatically consider all the data without any human errors. Okay. Do you have any questions? Do you have any questions? Okay. I must know my presentation is good, is clear for you, or no? Because this is my first experience. I must know. If you have any hint for doing the better presentation, I ask you to say me. Please say me about my presentation. If it is okay for you, we can continue. Okay. Okay. About the, we have different types of machine learning system. We have supervised, unsupervised, semi-supervised, and reinforcement learning. We have these types of machine learning system. Again, step by step, we must a little familiar with these words. What is the supervised learning? What is the unsupervised learning? Okay. Supervised learning. What is the supervised? As you see in machine learning algorithms, we have data. We must learn, the machine learning must learn from the data. Okay? Then, for example, we must label each data. Our cells must label the data. For example, we must label this email is supervised, this email is this email is okay, this email is okay, this email is spam email, this email spam. We must label each data. Okay, and then we feed this data to the machine learning algorithm. Okay. Then, using this label, the algorithm learn and train what is spam, what is not spam, and then after that, in the test, we feed the new email. And then set the algorithm. Okay, according your training step, you must evaluate this email. Okay. Again, this email also have label, but we must to know that this algorithm, this system, recognize it correctly or not. Okay, if recognize it okay, then we don't have error. If we don't recognize well, we have error in our diagnosis. Then if our error is high, we must think about why. What is the reason? And if our error is low, is okay. Our system is good. Okay. Another thing is in the supervised learning. If we have, for example, like circles, okay, such as the price of car. This circle is the price of car, for example. Okay. You see this arrow is related to feature, is the price of car, and this arrow is related to value. For example, the price of car, I don't know, one is white, is another. Okay. And then after the training, we access to this object, we access to the value of these features. And if we have the new feature, using the previous features, we predict it. It is the bottom figure is like the up figures, but the notation, the graphical is a little different. If you learn this, then the upper one, the lower is like the bottom. The context is similar. The context of supervised learning is that our data have labels. Okay, this is the important. But in unsupervised learning, we don't have any labels. We don't have any labels in our data. The machine learning algorithm automatically learn about the pattern of the data. They learn, okay, if they have this like a pattern, they are group, for example, 1. If the patterns are like another features, they are in group 2. But we don't say anything about this group. Maybe a human, maybe a human consider this data like this. Group 1, group 2. Okay? Maybe another person classify like this. In yellow. 1, 2. Maybe, I don't know, another person classify this data to like this. Group 1, group 2. Okay? But the machine learning algorithm, it's themselves decide how to classify the data. For example, they classify this data to 4 groups. How do they decide? It depends on algorithms. We don't know. There are different algorithms. At this moment, we don't know. But by different algorithms, by different targets, by different purpose, maybe they classify the data to 4 groups. Okay? Then the data don't have any labels. This is unsupervised learning. According to the time, and I said about the semi-supervised, and then we will finish the course. Another algorithm is semi-supervised learning. What is the difference between them? Since labeling data is usually time consuming and costly, we must label, okay, this is triangle, then we label it like 1, 1, 1. This is a square, then we label it 2, 2, 2. Here is not infinite, but maybe we have large amount of data. Anyway, they may be time consuming and costly. We have our data, some of our data have label, but some of our data don't have label. The triangle have label, but the circles don't have labels. The squares here, the orange squares here is label, for example 2, for example. But the circles around them don't have. And if we have a new object and we want to know the triangle or a square, then using similarity parameters, similarity evaluation, the machine learning algorithm decide it is triangle or it is a square. For example, if they have 3 angles, it is a triangle. If they have 4 angles, they are squares. You know, some of our data have label, some of them don't have it. Then it is semi-supervised. Semi-supervised is the mix of supervised and unsupervised. Okay. If you don't have questions according to our time, we will finish it, and in the next session we will continue it. Okay, if our class time change, I will inform you in the Telegram group. Thanks so much for your time and listening to my presentation. I hope to have a good time and be successful. Thanks. If you don't have any question, we finish it. Thanks you.